Hello everyone, welcome to my channel. My name is Rudra and today we are continuing Python programming series. So in previous lecture number 7, we studied functions. Today is lecture number 8. So in functions, we studied about type of functions, recursive function and calling a function, defining a function and everything. Okay. So I hope you have practiced a lot of portion on function because function to get familiar with function it requires a lot of practice to get hang of it. Okay, so without wasting any time, let's see what we will study in this lecture number 8, collections. So in this lecture we will basically study about how we can store data in Python. How can we collect data or store data in Python? So we'll study about different type of collections like list, how to create list, index, slicing of list and other things. Then tuples, sets and dictionary. These are basically different ways in which you can give data to Python to work on. Okay, so without wasting any time, let's start with topic 1, which is lists. So creating a list. A list is an ordered, changeable, mutable collection that can store multiple values, even of different data types, in a single variable. Lists are written using square brackets with items separated by commas. So there are few things to note here, which is lists are ordered. Ordered means in which order you store the data in the list, it will be in that order only. They are changeable, mutable. It means after creating the list, the elements what you store inside the list are generally called elements. So whatever you store inside the list, they are changeable. It means you can change the data inside the, and you can store different data types in list in a single variable. So in some you might be able to store only one type of data, but in list not the case. Okay, and how list is written using square brackets. So here we can see the examples, and the items whatever you are storing in the list are separated by commas. So we can see an example here. Here fruits is a list. You are creating a variable uh, which will store a list. Okay, so here apple, banana, mango, you are here as we studied before. Here are square brackets enclosed by square brackets, then separated by commas. Okay, these are the apple is the element, banana is the element, mango is the element in this list. Other example like you are creating a list of numbers. Okay, so you are storing, because these are strings here, apple, banana and mango, that's why they are enclosed in quotes. Okay, here in integers generally aren't enclosed in numbers, strings are. Okay, that's why here they are, but they are separated by commas. As you can see, what are the elements of numbers list? It is 10, 20, 30. Mixed in list, it is also possible to store mixed data types, like here it is a string, here it is in integer, then here it is a float, then here boolean. Okay, so and you can also create an empty list, which later if you want to store data in it, if you want to add something to it, you can add later. So here as you can see, then printing, you can print here, and you can find the type of the variable here, which is fruits. So here it will give you list. So list has been created here. Fruits, here is list. What are key points? We have already talked about these key points. Lists are ordered, items keep the exact position they were inserted in. So you have to make sure in which order you added the items in the list. So keep that in mind. Lists are mutable. Items can be changed, added or removed after creation, unlike strings. Lists allow duplicate values. like 1 comma 2 comma 2 comma 3 is valid. So duplicates are allowed. A list can hold a mix of different data types, even other lists. So a list can contain a list. Okay, that's called nested lists. You should keep that point in mind. The length of list gives the number of items in a list. So if you find the length of this list, so it will give the number of elements, like number of things separated by comma. So 1 2 3 4 4. The length of the list will be this list will be. Now, what is list indexing? Indexing is used to access a single item of a list using its position number. Just like strings, list indexing starts at 0 and negative indices count from the end. So we have already studied indexing in strings, and indexing in list is completely similar to that. Here, if you want to access, now you have created the list. Now if you want to access the elements in the list, like if you want to access the second element, third element, fourth element, any, if you want to access the data from the list, then what you use indexes. So here, print fruits, square brackets, we have we write indexes like this. We also did this in when we are studying strings. Okay, so 0. So what does 0 specify? 0 says that apple will be printed first item. Okay. Because how do indexes start from 0 1 2 and 3? So here as you can see in this, when we write 0 here in fruits, so what will be printed here? Apple will be printed. Then if you write 2 here, then keep one here, 0 1 2, mango will be printed. Then minus 1 is 1, minus 1 signifies the last element. Okay, so grapes will be printed. And here it is showing that we can change the values in the list. Here at one position, at one index, here we are assigning a new value to it, which is an orange. Okay, so as we can see example, we did a plenty of processes here. Let's see what's the result at the end result. So for the first, we is printing apple, then it is printing mango, then here it, in this case it is printing the last item, which is grapes. And here we are modifying the list. So let's see here, the new list becomes this: apple, orange, mango and grapes. So here it shows that you can change the list like this. You can change the element which are inside the list, which is not possible in case of string. Okay, so key points: unlike strings, list items can be changed directly using their index. This is possible because lists are mutable. Accessing an item that doesn't exist causes an index error. So if you write any index here, which is at which no item is there, no item is element is there for that index. So what will it do? It will show index error. Like in this case, in above example, if you write index here, let's say what are the indices in this list where items are stored: 0 1 2 and 3. If you write 4 here, then it will show index error. Now let's move on to the next topic, which is list slicing. We have studied slicing in strings as well. It is exactly same as it was in a string. We are just breaking the list in parts according to our requirements. Okay, so slicing extracts a portion sublist of a list using list start colon stop colon step, following the same rules as string slice. The stop index is excluded. So this is the syntax which was similar to string as well. So what we will specify, where to start the sublist, then where to stop and step if we want to skip some elements. Then the output list will be the sliced list. So here, as you can see, we will see this with an example, which is numbers. So here it is a list of numbers 10, 20, 30, 40, 50 and 60. So in first case, what we are doing, we are slicing it from 1 to 4. So index 1, so index 1 is at 20 and start part is included. This index is included, stop part is not included. Okay, so it will go from 1, 2, 3, 4 will not be included. So the new list will be this list, which will contain 20, 30 and 40. Then in the second there is 3. So here we will get what we will get. If there is no start, so start will be from 0. So from 0, 10, 20, and since 3 is not included, then here is like this. Then here, as you can see here, 3, we are starting from 3 and there is no end. Okay, so it is like this. In second case, it is printed 10, 20, 30 because 0, 1, 2 till 2 it will go there, 3 will not be included. In third case, we are starting from 3 and 3 is included because starting index is included. So where will be 3? 3 will be here, 40 at 43 will be there. And since no end, no stop is specified, so it will go till the end of the list. Here it is 60. So 40, 50, 60 will be there. Then here we have not provided a starting point and a stopping point, but we have provided a step index, how many times we have to step. So we have to step 2 times. So first 10 will be printed, then we have to step 2 times, 1, 2, then we will print 30, 1, 2 steps, then we will print 50. So 10, 30, 50 will be printed. Similarly, in the next, we are printing the list in reverse order. You should remember this is the syntax I also taught you how to reverse a string as well, where this is the syntax. So it reverses the list, as you can see. What does it signify? What does it means? Here there is no starting index, there is no stopping index, but we are stepping -1 times. So since it is -1, so we are stepping backwards. So what we will do, -1 signifies this position and we are stepping -1 time. So basically we are going backwards. So first 60 will be printed, then -1, then 50, then 40, then 30, then 20. Slicing always returns a new list. The original list is not changed. So whatever you are doing here, all these processes, they are creating a new list. Okay, here these numbers list does not change. Okay, so you might have seen in variables, like when you operate on variables, if you are storing an integer in that, then you do some use, let's say you are numbers, you are assigning 20 in that, then what you do, you add 1 to that number, like number is equals to number plus 1. So the new number will get updated and it will become, if you are adding 1 to it, it will become 21. So that variable, that whatever you are storing, that thing changes. But in case of lists, when you are here slicing, so when you sliced it first time, okay, so it became this, but after that when you sliced it second time, it didn't operate on the first list. Okay, it operated on the main list, which is here number. So that's what it is saying here, that when you slice it, new list is created. And you can also store it here. You can, what you can do here, instead of printing, if you want to store this list, okay, if you want a variable in which this list is stored, you can say number 2 is equals to numbers 1 colon 4. That's how second, that would become a second list. So list colon double colon minus 1 is a quick way to reverse a list. Same trick as now. List methods. List methods are built-in functions used to add, remove, search, or recognize items inside a list called using list name dot method name. Okay, so these are built-in functions. Okay, in a list, when you are working with a list, the Python gives you built-in function to make it easy to add, remove, search, or reorganize stuff in the list. So we'll see few methods like append. Add item X to the end of the list. If you want add a item to the end of the list, then you will use append method. How it is used? Let's say fruit is the list here, so dot append kiwi. So kiwi will be added at the end of the list. Okay. Insert here ix. This is the syntax. Insert item X at index I. So if you want to insert some elements, you can do it like that. You want to remove something, you can do it like that. Pop removes and returns item at index 1, last item if empty. Okay, so it will remove and return. Okay, it will perform two functions. How it is different from remove? Remove will just remove the item. Pop will remove it and return it. Okay, clear, remove all items from the list. If you want to make the list empty, then you can do clear. Index returns the index of the first matching item. Okay, so it, in this syntax it will print if mango is at index 1, then it will give us what? Count. So how many times anything appears, how many duplicates are there in of something X in that list. So it will do that. Sort the list in ascending order in place. Okay, reverse, you can reverse the list using this as well. You can reverse it in that way using this method as well, and you can do it this with this method as well. Copy returns a copy of a list. Extend, add all items of list 2 to the end. So if you want, there are two lists, okay, and you want to add a list to all the elements of list 2 to the list 1. So what you do, you do extend list 1 dot, here this is the list dot extend, and you do this, you write this list, and it will get added at the end. You can see all the examples here. We'll solve few questions in this in some time. Okay, so you can read these examples, pause the video, read the examples how they are working. I'll just iterate you for that. Like here is a list of numbers. Okay, so we are here, we are appending using append 60. So what will be 60 will be added at this position after 20. So as you can see, first output like this. Now we are sorting. So sorting, what does it do? It sorts them into ascending order. So it will become 10, 30, 10, 20, 30, 50. So now the new list has been created. So it's new, not the new list, an extra element has been appended in that. So 60 will be there. So this is the sorted list. Then we are removing 10, 10 is removed. Then we are reversing the list. Is key points. Most list method modify the list in place, directly change the original list. So as you can see, when we are slicing, during slicing, new list is formed. But when we apply a method to a list, it changes, it modifies the original list. Okay, no new list is formed at that time. That's why when we are doing, when we first did this method, applied this method, then it added 60. Then second method, 60 was already added to the list. Okay, as you can see in the output, 60 is already present. Okay, as we are applying the new methods, we can see the list is changing. So at the end, all the list, at the end, if you write something new here, if you do any new method, so that method will be applied to this last list. Okay, because in place methods work on the list in place manner. They are methods are in this way different from slicing, because in slicing new lists are formed. So, and return none. Example, numbers is equals to numbers dot short would incorrectly set number to none. Append adds a single item even if that item is a list. It gets added as one of the nested item, while extend adds each item of another list individually. So append, what does append do? It just adds a single item at the end. And what does extend do? Extend adds two list elements. Like if you will append a list, we can we can see this. If you are appending, let's say there are two lists, okay, one is fruits and other is uh, you can say fruits too, or anything vegetables, okay, let's say two lists are there, vegetables and fruits. If you write fruits dot append and you write the vegetable list, then what will it do? Append will add a, it will form a nested list. It will add the vegetables in the fruit in form of a list only, okay. So it will become a nested list. But what will extend do? If you do fruits dot extend vegetable list, then it will add their elements together, it will form a new list. And not new list, it will modify that first list, fruit list, by adding the elements of vegetable list at the end, okay. That's the difference between append and extend. Now list comprehension. List comprehension is a short, elegant way to create a new list by applying an expression to each item of an existing sequence, optionally including a condition, all written in single. So it's not that popular. I mean, it's a concept, so I'll just teach it, but it's isn't used that much in coding. Okay, so it's advised to just normally operate on the list, or normally create a list and stuff. So let's just see. New list expression for item in sequence if condition. Okay, so this is the syntax. So here we can see with an example squares, we are creating an empty list. Now for x in range, so squares dot append x star x, so print squares. So this list will be printed. This we are appending, what we are doing, we are running a loop, and one by one, like we are appending whatever x star hash. So first one will come, so here append will add one, so one will be added. Then after one, two, next iteration, two will come, 2 square 4, 4 will be added, then 9 will be added, then 16 will be added, 25 will be added. This is the long way where we normally do it, okay. Then the same result using list comprehension. What we do is squares is equals to star dot x for x in range. Yes, okay. So it will give the same result, but sometimes I will advise you to not do this. You can definitely do this in this manner because it's more readable. Anyone who has studied, you have just started list and you know this concept, okay, you know for loop, you know how to create a list, this is an empty list, you just studied about append, so you can make of it what is going on, it is readable, okay. But this is not that much readable, okay. So for this question is easy, so that's why it seems very easy, like you are just writing the expression for x in range like this. But if the questions become complex, okay, the values we are storing in these conditions become complex, then error might happen, okay. So it becomes complicated a little bit. So here is another example with condition. So we already have a list even only, so we are creating a new list from this numbers list, n for n in numbers if n, here we are finding the remainder. So if remainder is equal to 0, so we have to store. So here as you can see 10, 20 and 30. So this is the syntax. Okay, key points. You can also do this in this manner, which is more readable. So list comprehension is faster to write and often faster to run than an equivalent regular for loop with append. The if condition part is optional. It's only needed when you want to filter items. Very widely used in real Python code, so it's worth practicing until it feels natural to read and write. Okay, if you are a beginner, then you can definitely do the questions like this, but if you want to master it, you can practice a lot of question on it. Okay? I will advise you to get a hang of it, because normally when people are at first, people normally modify or work on list using loops and stuff, if else statements. Okay, so if you want to master the list comprehension, then I will advise you to practice many questions, different type of questions on how to do it. Okay, so lists are complete. Now next part is tuple. So let's move on to our topic number 2, which is tuples. Now let's see what are tuples. A tuple is an ordered collection of items similar to list but immutable. Once created, its items cannot be changed, added or removed. Tuples are written using round brackets. Okay, so why, first of all, let's understand why do we need different type of collections like list and tuples. So as you can see, list is mutable. You can change it. So when you are working with a user, so you don't want in any way that the user can change the already created collection in your database. So then you can use tuple, because if user is working with the program, working on the program, so if he is working with a tuple, then it is not easy to change it. If the data inside the collection is not to be changed by the user, then we use tuple for a little bit security reason. Okay, so let's see how it is different from lists. It is similar to list, but it's immutable. One difference is that is immutable, and its item cannot be changed, added or removed. Okay, so that's one thing, and it is written with brackets, round bracket. So creating and accessing a tuple. So similar to list, here a tuple is created with round brackets, and at first we are printing the whole tuple here, so all are printed. Now we are accessing the elements using indexes. So here we are getting the output red and blue for 0, and the minus for last item, which is blue. Here we are slicing, okay, slicing the tuple, so we are getting red and example tuples are immutable. So colors is equals to red, green, blue. Now you are assigning a new value at an index 0. So you are at place of red, you are trying to replace it with yellow. Okay, so this will cause an error. Type error, tuple object do not support item assignment. So there's that. Common tuple operations. Length, you can find the length of a tuple. Okay, concatenation, you can add two tuples to create a new tuple. Repetition, so you can create a tuple by, you can, like, there is a tuple, okay, you want to repeat it 3 times, so you can use this syntax and it will, the elements in it will get repeated. Membership, red in colors, true, so you can find if anything is using tuple, if any element is present in tuple using this. Count, you can count the number of times element repeats in a tuple using this syntax. Index, okay, you can find the index of any element in tuple. Key points: a tuple with a single item must include a comma. 5 if you are, this is not the case with list, okay, but in case of tuple, if there is only a one item in the tuple, so you have to write comma. Why is this significance? Because then, so that the python knows that what you are writing in brackets is a tuple, okay, because we can write multiple things in a bracket, okay. We use bracket at different types in many places in python. So to differentiate between those and a tuple, this is the syntax that we have to follow. So if there is an one item in a tuple, so we use comma for that, because round brackets 5 is just a number 5 in brackets. So to differentiate it from that, we use comma. Since tuples cannot be changed, they are useful for storing data that should stay constant throughout the program. I have already talked about this example: fixed coordinates, RGB color values, etc. Tuples only have two built-in methods, count and index. Far fewer than list since they cannot be modified. In list we had many methods, append, extend, and everything a lot more. But in tuples we can only count how many times an element is present, and we can only find the index of particular element in tuple. Tuples are generally faster than list for read-only data because of their immutability. So an MCQ based question might be asked on this topic. Which of the which of them is faster, tuples or list for read-only data? So answer is tuples. Now let's move on to the next topic, which is packing. Now what is packing? Packing is when multiple values are combined together into a single tuple automatically just by separating them with commas. So here, as you can see, the different values by commas are only, you are packing the different values in the tuple. So this is how it works automatically. So Python automatically, if there is no, if you are not covering it, if you are not enclosing it with a rounded brackets, Python automatically does that for you if you are separating them with commas. So now student has become a tuple. This is called packing. Parentheses are actually optional when creating a tuple. The comma is what really defines it. Okay. Packing is commonly used when a function needs to return multiple values at once. Covered further with unpacking below. After packing, let's talk about unpacking as well. Unpacking is a reverse of packing. It means extracting the individual values from the tuple or list directly into separate variables in a single line. So first there is this tuple. Now what we are doing, we are unpacking it like this. So name, age, city is equals to student. So now first index here, which is at 0 index, it will get assigned to name. Second index, which is 1, which is 21, so it will get assigned to age. So now it means we are here assigning the content of the tuple to the variables, okay. Then we will print them, and as you can see result here, amount 21 Delhi, they are printed. Unpacking with star, collecting extra values, okay. So here, as you can see first, so in star all the extra values, first, last, first, middle and last. So here in case of first, 10 is printed here with star middle. So all of them which comes in middle, they will be printed in form of a list, okay. Makes do remember that if you are using this, the output will be a list, okay, when you are printing, storing a bunch of them in a single variable. So it will be stored in a form of list, not tuple. The number of variables on the left must match the number of values in the tuple unless you use star to collect any extra values into a list. Unpacking also work with list and is the same mechanism used in variable swap trick. Okay, a comma b, we have already seen this. A comma b is equals to b comma a from lecture 2. Now we have studied tuples. There are not many functions or modification in tuple. Tuple is short because it is immutable. We can't perform many things on a tuple. So, but you should remember few things like it's immutable. Okay, when it is used, how to create a tuple when there is only single element. These are few things that you should keep in mind. Now moving on to the next topic, next type of collection, which are sets. So let's continue with sets. A set is an unordered collection of unique items. It automatically removes duplicate values and does not maintain any fixed order. Sets are written using curly braces. So sets are very different from tuple and list. As you can see, tuples are similar to list except for their immutability and how they are represented like round brackets like that. But sets are a lot different from list, like they are unordered. If you have stored something in a set, then their order, if you're printing it the first time, then second time, then their order might not be same. Order might change, okay? And it stores unique items, means no duplicates, okay? If you are storing duplicates, then it will automatically remove duplicates. So, and it is written using curly braces. So here you can see, here you have created a set with curly braces. As you can see here, there are duplicate apples. When you will print it, it will not print them. Okay. Here, as you can see, there are two apples, but when you print the set, it will print only this. Notice that duplicate apple was automatically removed and printed order may not match the order items were returned. Sets are unordered. Mathematical set operations. So you have might have studied this operation but in maths sets. So these are same. Here union A straight line B or A dot union B. Here all items from both sets, no duplicates. Intersection, common elements, items present in both sets. So here is the syntax. Difference, items present in A but not in B. Okay. Symmetric difference. Okay, this is the symbol for that. Items in either set but not in both. So these are the few mathematical set operations, and you can see the example here. Here there is set A and set B. Now we are printing the union. We are doing union. So in union, all the both sets will be added together. Both the elements will be concatenated together, but it should not. As you can see, the both sets will be concatenated, but the items, the same duplicate items will not be present there. As you can see, there are 3 and 3 in both and 4 and 4 in both, but only if when you will use union, only 1 2 3 4 5 6 will be printed as shown here, output in output. Then there is intersection. Intersection means common elements in both sets. So here is 3 4, here is 3 4, so 3 4 is printed. Difference is elements present in A but not present in B. So one, as you can see, 3 and 4 are present in B and A. So you are doing difference, so you will remove 3 4 from 1. 1 2 will be printed. Symmetric difference. Symmetric difference means the elements which are not same in both sets. So 1 2 is, as you can see, 3 and 4 are common in both sets. Okay, so except for those, everything else will be printed. Key points. Sets automatically eliminate duplicates, a very common use in quickly removing duplicates from a list. List set my list. Okay, So you can first create a set, then you can convert that set. First there is a list. If you want to remove duplicates from that list, convert into a set like this, and then again convert that set into a list like this. Since sets are unordered, items cannot be accessed using an index. Example, fruits is valid for a set. An empty set must be created using set, not curly braces. Actually creates an empty dictionary. So you have to keep this in mind, like this is an importance of, if you are creating an empty set, like when we are creating an empty list, then we are using square brackets. Okay, like here it is an invalid for a set. Point 2 is also, first let's talk about point 2. Okay, point 2, since sets are unordered, so indexing doesn't work in sets. So you cannot access any element in a set like that because they are unordered. There is no order. If you call for 0 index first time, then you might get a different answer. Then if you call for the same index again, then you might get a different answer. That's why accessing using an index is invalid in Python for sets. Now third point, an empty set must be created using this syntax. Okay, so when you are creating a list or a tuple or anything, then you can just create a tuple and list in a simple manner. But like in list case you are using square brackets, in case of tuple you are using round brackets. But in case of set, you create sets like with round brackets, not curly braces, because with curly braces it actually creates an empty dictionary. Now let's see some set methods. First is add a single item X to the set, remove, discard, okay, pop, clear, union, is subset. Okay, these are all related to sets you have studied in mathematics class 11th, I think. Okay, so you can read the descriptions of all the methods here and how they are used. You can see the syntax, each syntax, how they are applied, and the example is here. So you can read the example. Let's see what are some key points here. Use discard instead of remove if you are not sure whether the item exists. Remove raises an error if the item isn't found, but discard does not. Okay, so keep this point in mind. Because sets are unordered, pop removes an arbitrary, not necessarily last item. So if you are using pop, so not used that much. Okay, so here if you are using pop, keep that in mind that it can remove any element. Okay, any element of the set, because they are unordered, they interchange. Okay, so there is no fixed place for the elements in sets. Now it's time for dictionaries. So let's continue with the dictionaries. Creating a dictionary. A dictionary is a unordered insertion, ordered since it was inserted in this Python 3.7 plus. Okay, since this Python version was included in Python. So let's continue with the definition once again. A dictionary is an unordered, changeable collection that stores data as key value pairs. Each key must be unique and is used to access its associated value. Dictionaries are written using curly braces with key colon value pairs. So in dictionary we basically store the data in paired way, where one is the key which helps us to, one is key, one is value. The value is stored with the key, and to access that value we use the key. Okay, so here we can see with example, like students curly braces, then we are, this is name here is key and it is, and the value is Aman. Okay, so this is a key value pair, then age separated by comma, then comma, then age 21, then comma, then city and Delhi. So there are three key value pairs here. Okay, so if you want to access these names and this, then you can use name, age and city, which are key here. So here we can print the dictionary like this, and we can find the type of collection, what it is. It is a dictionary. Accessing and updating values. So print, here we are, as you can see here, we are accessing with the key. So accessing a value using its key, so what will we get? We will get the value which is Aman here. Then age, we are changing here, we are updating the value, we can update it, and then we are adding a new key value pair. Okay, so like this. So we can print the new dictionary, which is first Aman is printed because we are accessing, then we are changing the value of age, so age values gets updated. Then after that we are adding a new key value pair here, which is country India. Okay, so we studied four different functions here. Key points, values are accessed using their key in square brackets, not by numeric index like list. So here we don't use index, we actually use key here. Key must be unique, so key can't be same here, like you can't create a key of name of this name again in the same dictionary. Okay, so all the keys should be unique. If you repeat a key while creating a dictionary, the last value overrides the earlier one. So in sequence wise, if there is a duplicate, then the last one will be considered, not the first one. Keys are usually strings or numbers. They must be an immutable type. Values can be of any data type, including lists or other dictionaries. Okay, so accessing a key that doesn't exist using square brackets cause an key error. Using dot get key instead returns none safely if the key is missing. So if you are not sure if any key is present in the dictionary, if you use the square brackets method, then it will show key error. If you want to avoid errors of this type, then you can use this method, which is get the key. So if there is no key of that name, okay, if there that key doesn't exist in the dictionary, then none will be printed as an output instead of an error. Keys and values. A dictionary provides special methods to retrieve just the keys, just the values, or both together as key value pair. So if you dot student dot keys, then keys will be printed. Student dot values, values will be printed. Dot items, all of them key value pairs are. Looping through a dictionary. So for key comma value in student dot items. Okay, so print key value, so it is printed like this. This is the way you look through a dictionary. Key points, dot keys, dot values, and dot items are all return special view object. They can be converted to a list using list if needed. Example, list. These were, we are getting the keys, right? We are accessing all the keys here. We are getting all the keys which are present in a student. If you want the list of those keys, so we can just enclose them in brackets and write list, and list will be formed. Using dot items inside a for loop with two loop variables is a standard way to go through both key and values together. So dictionary methods, there are different dictionary methods: get, update, pop item, clear, copy. You can read the descriptions here, and you can read the syntax here. Go through all the pause the video, go through all the descriptions and what does the different methods do and how they are used in what syntax. Okay, you don't have to remember all these methods. You can just read it for now, and with practice, as you are doing different questions, and you will or you will easily recall if they are asked in further in future question, if they come in any future question or problem. So here is an example. Key points: prefer dot get over brackets square brackets when you are not sure a key exists to avoid key error crashing your program. Update can both modify existing keys and add new ones in a single call. Now after dictionaries, there is dictionary comprehension. Similar to list comprehension, dictionary comprehension is a short way to create a new dictionary using a single line of code based on an expression and an optional condition. So here is the syntax. Name of the dictionary is equals to key expression, okay, in curly braces, curly brackets, then colon value expression for item in sequence if condition. So here is an example: x colon x star x, which is x into x for x in range. So print squares. So here is the key expression, which is an x. Okay, then so basically what does it signify? This side of colon, it is the key, this side it is the value for x in range. So the x in range 1 to 6, so it will loop through these range. First 1 will go at place of x, then 2, then 3, then 4, and one by one it will be stored, it will form a dictionary. Okay, it will be stored in a dictionary like this. First it is 1 1, then it is 2 4, then 3 9, 4 16, 5 20. With the condition, if you want to add a condition, then similarly here, after that you can, after range here this way, you can, if you want, you can add a condition as well. Key points: a syntax follows the same pattern as list comprehension but uses key value instead of expression. Very useful for quickly transforming an existing list or dictionary into a new dictionary without writing a full loop. So these are its advantages. Okay, if you are facing any problem in understanding this the first time, you can practice, definitely practice few questions, read through the syntax 2 3 times, okay, and practice a lot of question on this. So end of lecture at 8, which is collection. In this lecture we studied list, tuple, sets and dictionaries. So lecture part is complete. We will do few questions. Okay, I have the practice sheet, practice question for this lecture number 8. So without wasting any time, let's continue with practice question. So first let's go to VS Code. I have created a file for lecture 8. Here we will do the questions. Okay, so let's see what is question number 1. Question number 1 is student marks. Okay, we have to create a list, work on a list, create a list in which we will store something related to student mark. Write a program that takes 5 marks as input from user and stores them in a list. Print the highest marks, the lowest marks, the average marks. So first, very simple questions. If you, we can do this using the list methods. There are few list methods. Okay, so let's do it. So the main part of this question is how you will store the items in this. You basically have to take input from the user. Okay, so if you are taking input from the user, since you are storing 5 items, then you have to iterate the input statement 5 times, then only the user can enter 5 values, right? So we have to do that. So for that, let's first create a, we have to store student marks, right? So create a list student marks. How did we use, how did we learn to create a list? Use square brackets like this. Now marks list has been created. Okay, so now we have to store it. So for I in range, we have to store 5 items. That's why we take 5. Here the, how do you want to take the entry, take the input? So for the input we will create this variable mark. Okay, it is different from the marks list, so there should be no, enter marks. Yes. We are using method append to add the input into the list. So input was this. Now list has been created and we have taken input from the user. So now we have to print few things. What was the, we have to print highest marks, lowest marks, and average marks. Okay, so first let's print highest marks. So we are taking the input, but we are in question. It is not shown that we have to print the list. I think we should first print the list as well, so we can see that the list is correct according to the users. So first we will print the normal list, then we'll print the highest marks. Now what's the method for that? It is max. We can use this. Similarly, there is a method for lowest as well, which is minimum, and there is a method for finding averages as well. How to find what is the average? Sum of all the elements, divide by number of elements. We have written the highest, lowest and average. So let's run the program. Let's see. First, let's clear the now we have to enter marks. First, let's say 60, 60 then 90, 85 for random numbers. So we gave the marks for 5. Okay, so we can see here we can take the input of the marks in more clear way. We can read enter marks for check. So the this becomes more readable. Okay, what I have done, I have formatted this, and why I have done I plus 1, because I starts from 0, right? So for the first iteration it will print 1 2 like that. Let's clear it. Let's do it again. As you can see, now it is more kind of readable. So this is the least formed, highest is 90, lowest is 34 and average is 65 point. As you can see, question number 1 is complete. Comment that out. Now what is question number 2? Create a tuple containing 5 fruit names. Ask the user to enter a fruit name. Check whether the fruit exists in the tuple. If it exists, print its index. Otherwise, print fruit not found. So it is an easy. All the questions, there are 5 questions. Is practice sheet. So you can see all the answers are also here. It is second question is also easy. Just you have to create the tuple. Create any with any elements, then ask for an input from the user. So you can ask whatever you user will write. So you can use membership operator here. If fruit in fruits, print this index, print its index, and else fruit not found. So that's how you can do second question. You can try all this question I'll on your own first. Okay, answers are already given in this practice sheet below. I will encourage you to solve this question on your own first without any help. Then you can see the answers, and if you are facing still some problems, then you can check from any AI, Chat GPT, Claude to clarify the code how it is done. Okay, so lecture number 8 is done with the practice sheets. All the notes and the practice sheets will be provided in the description, so don't worry about that. So thank you everyone for watching till the end. Now we will meet in the next lecture, lecture number 9. Okay, so thank you for watching.